Hello, 7th graders. Today we meet again in online learning SMPK Penabur. I hope all of us and all of our family still in a good condition. After our previous meeting, we have learned about linear expansion. Now we will learn about area or superficial expansion. Standard competence. Standard competence for our topic today is 3.7. Understand the concept of temperature, expansion, heat, heat transfer, and their application in the mechanism of maintaining body temperature stability in humans and animals in daily life. And 4.10. Conduct the experiment to investigate temperature and its change and the effect of heat in temperature and state change. Area or superficial expansion. Before we learn deeper about area or superficial expansion, to understand about area expansion, firstly, we will see the figure of application of superficial expansion in our daily life. From the first figure, we see that we can remove tight metal cap of glass jar. We put the metal cap in hot water, or we can do in another way that we pour hot water above the metal cap. After we pour the hot water to the metal cap will be easier to be opened. And the second figure, you see that we can fix the iron rim on cartwheel. Besides the application of superficial expansion, there is problem of superficial expansion. In here, we see that because of superficial expansion, the crack on window glass can happen. Area expansion. If the solid object in form of thin sheet is heated, it will expand. Because of the thickness is too small compared with its length and its width, so the expansion on direction of thickness can be neglected. This kind of expansion we call as area expansion or superficial expansion. To understand about area expansion, let's see the figure below. From the figure, we can see that the metal plate has width L0 and has length L0, and the initial area is A0. So initial area A0 equals L0 times L0. And after the metal plate is heated, the length becomes L0 plus delta L, and the width becomes L0 plus delta L. So the area of metal plate after heated is AT, as we can see at the second figure, at the right figure. And the magnitude of area expansion delta E, an object, is influenced by three factors. The first factor is the initial area of the object, A0. The second is the change in temperature, delta T. And the third factor is the coefficient of area expansion, beta. Because of that, the magnitude of area expansion delta A can be formulated as delta A equals A0 times beta times delta t. From the second figure, we can see that AT equals final length times final length, or we can write L null plus delta L times L null plus delta L. That L null plus delta L is LT. So AT equals LT times LT. Because we know from our previous meeting that LT equals L null times 1 plus alpha delta t. So AT equals L null times 1 plus alpha times delta t times L null times 1 plus alpha times delta t. So after we multiply, we can get that AT equals L null plus L null times alpha times delta t times L null times plus L null times alpha times delta t. Because of that, we can get that AT equals L null square plus 2 times L null square times alpha times delta t plus L null square times alpha square times delta t square. Because of value alpha very small, so alpha square can be neglected. So AT equals L null square plus 2 times L null square times alpha times delta t. Or we can write AT equals A null plus A null times 2 alpha times delta t. From the figure, we can conclude that AT equals A null plus delta r, with entering the magnitude of delta A null times beta times delta t to the formula AT equals A null plus delta E. So AT can be written as A null times 1 plus beta times delta t. With comparing the two formula, AT equals A null times 1 plus beta times delta t and AT equals A null plus A null times 2 alpha times delta t. So we can get that beta equals to alpha. To get more understanding about area expansion, now let's see the 3 examples of area expansion. Let's see the example 1. A glass has area 2 meters square at 30 degrees Celsius. Determine area of the glass at 50 degrees Celsius. If coefficient of linear expansion of the glass is 9 times 10 to the power of minus 6 per degree Celsius. From the problems, given A null equals 2 meters square, and we can get delta t equals 50 degrees Celsius minus 30 degrees Celsius equals 20 degrees Celsius, and alpha, coefficient of linear expansion, equals 9 times 10 to the power of minus 6 per degree Celsius. Because we talk about area expansion, we need beta. Because beta equals 2 times alpha, so beta equals 2 times 9 times 10 to the power of minus 6 per degree Celsius. So magnitude of beta equals 18 times 10 to the power of minus 6 per degree Celsius. Ask AT, final area. Answer: AT equals A null times 1 plus beta times delta t. So AT equals 2 meters square times 1 plus 18 times 10 to the power of minus 6 per degree Celsius times 20 degrees Celsius. 80 equals 2 meters square times 1 plus 36 times 10 to the power of minus 5. 80 equals 2 meters square times 1 plus 2 meters square times 36 times 10 to the power of minus 5. So we can get that 80 equals 2 meters square plus 72 times 10 to the power of minus 5 meters square equals 2 meters square plus 0.00072 meters square. So we can get the AT or final area equals 2.00072 meters square. Example 2. A metal plate has area 1 meter square at 20 degrees Celsius. After that, the plate is heated up to area 70 degrees Celsius. If after heated, the area of the plate become 1.0017 meters square, calculate coefficient of area expansion of the metal. From the problems given, A0 equals 1 meter square, and from the problems we can get delta T equals 70 degrees Celsius minus 20 degrees Celsius equals 50 degrees Celsius, and AT final area equals 1.0017 meters square. Ask beta. Answer: AT equals A0 times 1 plus beta times delta T. So 1.0017 meters square equals 1 meter square times 1 plus beta times 50 degrees Celsius. 1.0017 meters square equals 1 meter square times 1 plus beta times 50 degrees Celsius times 1 meter square. So we can get that 1.0017 meters square minus 1 meter square equals beta times 50 degrees Celsius meter square. So 0.0017 meters square equals beta times 50 degrees Celsius meter square. From here we can get that beta equals 0.0017 meters square divided by 50 degrees Celsius meter square, and we can get that beta equals 0.000034 per degree Celsius, or we can write with 34 times 10 to the power of minus 6 per degree Celsius. Example 3. Window frame is made from wood. At 30 degrees Celsius, the window frame has area 3.0018 meters square, and the area of the window glass is 3 meters square. If coefficient of linear expansion of the glass 9 times 10 to the power of minus 6 per degree Celsius, determine the temperature when the glass contact the window frame. If expansion of window frame is neglected. From the problems we can get that given annual glass equals 3 meters square. Because the expansion of window frame is neglected, so we can get that the initial area of window frame we can use as final area of the glass. So 80 glass equals 3.0018 meters square, and T1 equals 30 degrees Celsius. And alpha glass, coefficient of linear expansion of the glass, equals 9 times 10 to the power of minus 6 per degree Celsius. Because of area expansion, we need beta, that beta equals 2 times alpha. So beta equals 2 times 9 times 10 to the power of minus 6 per degree Celsius equals 18 times 10 to the power of minus 6 per degree Celsius. Ask T2. Answer: 80 equals NO times 1 plus beta times delta T. So 3.0018 meters square equals 3 meters square times 1 plus 18 times 10 to the power of minus 6 per degree Celsius times delta T. So 3.0018 meters square equals 3 meters square times 1 plus 3 meters square times 18 times 10 to the power of minus 6 per degree Celsius times delta T. And 3.0018 meters square minus 3 meters square equals 54 times 10 to the power of minus 6 per degree Celsius meter square times delta T. So we get that 0.0018 meters square equals 0.000054 per degree Celsius meter square times delta T. From here we can get that delta T equals 0.0018 meters square divided by 0.000054 per degree Celsius meter square, and we can get that delta T equals 33.33 degrees Celsius. Because of that, we can get that T2 equals T1 plus delta T. So T2 equals 30 degrees Celsius plus 33.33 degrees Celsius. So T2 equals 63.33 degrees Celsius. To more understand about area expansion, let's do exercise from Science Fisika and Kimia grade 7, Intan Pariwara, page 142, number 33. I hope with these materials in the video can enhance your understanding about expansion. God bless you.